Welcome, everybody. This is Robert Hodges, and I'm delighted to welcome you to our webinar on Altinity.Cloud Anywhere and how it allows you to own your own data, but still have cloud management. We'll go into all the details in this talk. I'm joined today by Alexander Zaitsev. He's our CTO, who has been the driving force behind developing the software that we'll be showing you today in just a few minutes. So just a few introductions. Us here at Altinity, we're database geeks. We're also cloud geeks, as you're going to see in a few minutes. Collectively, we have decades, actually centuries of experience in database and applications, particularly analytics. About 2/3 of the company, we have 45 people in the company, around 2/3 of them are engineers. So we're pretty big on databases and the applications that run on top of them. The audience for this, we assume you are app developers. You're looking to build real-time analytics to solve business problems, probably on ClickHouse. You may, it's possible you haven't heard about ClickHouse. We'll give you a quick intro to that as well. And another thing is there's a good chance you like Kubernetes because we're going to show you how to run ClickHouse and have it fully managed on your own Kubernetes clusters. So some background on Altinity. We've been around since 2017. We offer enterprise support and services for ClickHouse, including Altinity.Cloud, which is was the first public cloud offering of managed ClickHouse in Amazon and GCP. Started out a little over around almost 2.5 years ago, and are plowing ahead. This is the latest iteration of the offering. We also do quite a bit of open source work. If you use Kubernetes, you may be familiar with our Kubernetes operator for ClickHouse. That's used by literally thousands of clusters, tens of thousands probably worldwide. We do a bunch of other open source projects as well. So let's just start by answering the question, what's Altinity.Cloud Anywhere? Well, it's a managed service for ClickHouse. But what's ClickHouse? So just in case you haven't heard about it, ClickHouse is a real-time analytic database. It's outstandingly fast and allows people to deliver very, very quick answers on rapidly arriving data, often millions of rows per second, where people need to know sometimes within seconds of events occurring in the real world that something has occurred that's of interest, and they then may want to go and look more deeply into the data. For example, if you have a security problem, doing analytics very quickly to discover the scope of the problem, where did it emerge, how long has it been going on, stuff like that. How does it do that? Well, it's a SQL database, so it talks a variant of SQL. So it runs on bare metal of the cloud. It's extremely portable. It runs anywhere that Linux does, basically from a phone to a Docker instance or container to racked equipment or VMs in the cloud. It has a shared nothing architecture, so it's attached. The basic architecture is that you have nodes. They have patches of storage that they own, and then they connect by a network. This model is evolving over time to be a more separated compute and storage model, but for now, this is basically how it works. And then other things that you expect in an analytic database: columnar storage, parallel and vectorized execution, the ability to scale to many, many petabytes, and it's open source. So all of these things taken together, it's become the most popular real-time analytic database out on GitHub. It has hundreds of unique contributors per year and thousands of users. So Altinity.Cloud runs this ClickHouse data warehouse or analytic database in the cloud for you. So it completely automates all the things that you need to do to set up and run ClickHouse, everything from initial installation all the way to upgrade, all the way to rescaling, bunch of tools for DBA support. The way that we design the cloud, it's optimized for both in terms of cost as well as performance for doing real-time analytics. So these are things where you have rapidly arriving data, often constantly arriving. You need answers on it quickly, and you need consistent response. It supports all versions and features of ClickHouse, so you can run any version of ClickHouse on it. There's some we don't recommend running because they might not be stable, but generally speaking, anything you can do with ClickHouse on a laptop, excuse me, you can do it in Altinity Cloud. And it runs in Amazon or GCP, or, and this is the new part, your own Kubernetes clusters. So the pure SaaS model is what most of our customers do right now. But what we know is that for many people, this isn't the right model. And because what happens is the data runs in our VPC, you don't have control of it. That has a number of effects that may or may not be good for different businesses. So often you want to run in your own VPC because you have security compliance requirements. You might want to use your own infrastructure because you can control costs better. You might want to keep things close to your on-prem or sort of data sources that you control. And this is a really important one. Many people want something that's 100% open source with the data under their control, just so that they don't have lock-in, and they can't be, in hoc to a vendor that, controls the data, has opaque software that they can't run themselves. Altinity.Cloud Anywhere solves this problem completely. So that's kind of a big boast to say that. And the simplest way to prove that is actually to show you, as opposed to spending a lot more time on slides. So let's do a demo. So we'll get out of the slides and we'll go to an Altinity.Cloud Anywhere cluster. And this is a cluster. This is what if you haven't seen it before, this is what the Altinity.Cloud interface looks like. We can go to let's show you where this is running. It's running in what's called an environment. We'll go in and have a look at it. This is basically a dashboard for an EKS, sort of an Amazon managed Kubernetes cluster that's running in US West 2, so up somewhere in Oregon, probably near the Columbia River. So you can see, Altinity.Cloud can see into this. We only can see a patch of we can basically see VMs, we can see and manipulate things in a couple of namespaces, but we have these stats that show us what's going on. We can also manage clusters in there. We've got a cluster in there. And using the standard Altinity.Cloud interface, we can go ahead and, sort of manage this directly. Let me show you, though, something that's also kind of interesting, which is we can show you this actually running in the Kubernetes cluster. So what I just popped up here is a kubectl command, which is the standard administrative command for managing Kubernetes. And it's just doing a watch command, and it's just showing us the pods that are running ClickHouse in this Kubernetes instance. So there they are. Let's have a look at the Kubernetes cluster. We can see these nodes that are available. That's where the pods are running. Pods are just containers. Let's make a change to this system using Altinity.Cloud, and we'll show you how this actually affects this local EKS cluster. And what we're going to do is we're going to do what's called a rescale operation, where we're going to add a node to this. So we're going to change this. Actually, I'll change this to I'll change it to 2 shards. That's fine. So what this is doing is just adding another replica, or adding another server that can support an additional subset of our data. I'll just go ahead and press OK. And I need to confirm this because this is going to start to extend the cluster. And let's do the following so we can see that this rescale operation should be starting. Oh, let me just make sure that actually started. Well, we can check because we have that's weird. This is clearly a day of bad luck. Somehow that did not start. Let me just redo that operation. Do rescale. So we're going to go to increase the number of shards. Okay, Alexander, I think we have a demo which for some reason is misbehaving, and I'm just looking at what's going on here.
No, it's going. You can
Okay,
see
great. All right.
Yeah.
Sorry, folks. I may have pressed the wrong button here. I think this is obviously not my day for webinar karma. So it's starting to do the upgrade, and which is great because it did it many times as I was practicing it over the last few days. So what's going on? Well, we can actually see that it's spinning up a new pod. I'm looking at this Kubernetes cluster directly because I can manage it directly. I set it up myself. And I can see that I have a pod that is coming up. Why isn't it already started? Well, normally these things are up very quickly, but what it's in fact doing is it I've got this cluster set up so that it will auto scale, and it's actually spinning up a new VM to take care of this cluster. So to take care of this new node in the cluster. This will take a couple minutes. So while it's doing that, I'm going to switch off real quickly, and we're going to go look at something else that shows the power of this model. And this particular cluster we're working on is running an EKS. That's very common among our users. It's super convenient to use managed services. Let's go look at another cluster. And this cluster is a little bit different. It's actually running in Minikube in my closet about 10 feet away from me here in California. So I'm going to go into this cluster and let's go ahead and go to the Explore interface and let's show the tables that are available in this cluster. So no tables right now. What I'm going to do is log into the machine in my closet with SSL. I'm going to make a table and we'll see if it can be seen by Altinity.Cloud. So here we go. So I'm logged into the machine in my closet. It's called Logos 2. Let's go ahead and talk directly, use kubectl to talk directly to our ClickHouse instance. We're just going to go straight into the pod, and then we're going to start the ClickHouse client. And now that we're here, we're going to create a table called foo. So I've just created it completely locally, going from my laptop over my wireless network to my machine. And we'll do a show tables. And there it is, table foo. Let's go back to Altinity.Cloud and let's run that. This is now coming from US East 1, which is where this is running. I'm going to do a show tables. And there you are. That table is now visible to Altinity.Cloud. So this is an example of the power that you have with this model, that you basically have what amounts to installed software installed on Kubernetes, which means that we can actually set it up so that it will run in practically any environment, because Kubernetes runs just about everywhere. But at the same time, we have full cloud management. I can go provision new, I can extend this cluster, uh, you know, upgrade it, do all kinds of things. But I can do it all from a central management plane. So I have the cloud convenience, but I have full control over the actual infrastructure and the data that it's running on. Let's go to our Anywhere 3. Hopefully we'll find that it has brought the 2 nodes online, and there we go. So the cluster now has 2 nodes. If we consult our little go look at the cluster, you'll see that another node was allocated. We previously had 5 or 4, now we have 5. And both pods are up, fully running. So this shows that basically, you have a full a complete cloud experience for managing this, but it's running on Kubernetes clusters, and it's not just restricted to clusters that run in the cloud. It can actually do, manage a cluster that's running on-prem. So that's the demo, and I'm going to go ahead and sort of move back to the slides. And what the rest of this talk does is it shows you how to set this stuff up and have this for yourself. So let's go ahead and do a slideshow. So a little bit of background here. We call these Kubernetes clusters environments. In fact, that's what an environment really is. It's a Kubernetes cluster underneath. And in the traditional Altinity.Cloud, we run them in our own VPCs, and we just provision them soup to nuts, take care of everything. What is going on with Altinity.Cloud Anywhere is we're now using exactly the same model to have a Kubernetes cluster, except that it's somebody else's Kubernetes cluster, not ours. And to make this work, we add one key piece of technology, which is called the Altinity connector, and it's basically an outbound. It's a pod or container that runs in your Kubernetes cluster, and it sets up a secure outbound connection using HTTPS that comes to Altinity.Cloud and basically allows us to then set up a bidirectional management channel. We don't move data. It's relatively low bandwidth, but it gives us the ability to reach into these clusters securely and actually manage them. What I'm going to do now is show you how to do this, what's required to set this up, and then from there we can compare some of the differences between using this style of own your own Kubernetes versus running it in our VPCs. So it's basically 3 steps. The most complex one is to prepare Kubernetes, but if you're a Kubernetes person, you won't find it too bad. We then register with Altinity.Cloud and we're off to the races. So let's go ahead and we'll talk about the first part, which is preparing your Kubernetes cluster. First question you might ask is, well, which one? Right now, of the folks that are using this, most of them are running on EKS, which is the Amazon managed service, or Google Kubernetes engine, which is GKE. Minikube you can use, but we only use it for testing and demos. I would not ever recommend running something production on this. We are working on certifications for Azure, Red Hat, and DigitalOcean. So if you have those, you can come talk to us and we can work on it. But these guys here over on the left side are the ones that we work with most commonly. So in this particular case, I'm going to pick EKS. That happens to be the most widely used managed service at this time, and at least among our customer base. And what we're going to do is set it up soup to nuts. I'll show you the path. Now, just to be clear, normally when you set this up, you would, if you're running this at scale and want to make sure that you can repeat it and control the configuration, you use Terraform. I'm going to use tools to do this, but command line tools, because it's easier to see what's going on. The parts that we have to do are pretty simple. You really have to do 3 things to get started. The first is you have to provision a cluster, so you have to set one up somewhere. The second thing that you'll need to do, and this is once you have a cluster up, it will have 1 or more master nodes, which you may or may not be able to see depending on what version of what distribution you're using. They have system services, they have storage, but for our cluster in EKS, we won't be able to see that. You then have worker nodes, which actually contain the services that you're running. I'm just showing a couple worker nodes here, which contain ClickHouse pods. You'll need to have some kind of auto scaling because, or typically, you don't have to, but it's the most efficient way to run, so that as you add new nodes, we'll automatically allocate new machines or new VMs in the cloud, and then if we take away nodes, they'll be deallocated, so you won't waste money. That's the second thing. And the third thing is you need to make sure that you can manage block storage for data. This kind of works out of the box, but in the case of EKS, there are some new changes around drivers that we'll talk about, which require you to do some extra work to make sure it works fully. So let's just go through the steps. I'm not going to go through the details, but just give you a sense of how this works. So we use EKS CTL, which is a really handy command line utility for setting up EKS clusters. It only works on EKS. It's not portable, but if you're committed to Amazon, this works great. If you're on GCP, you would use gcloud commands, for example. So here's the way that I did it. You start with bringing up a jump VM. That's a simple way to do it, and the reason is that with Amazon, you can then build a role and assign it to that VM, which then means that the VM has the mystical powers required to set up CLI or set up EKS and do a bunch of other stuff related to it. And between those 2 steps, you just install a bunch of software like the Oz CLI, EKS CTL, kubectl, and the Oz IAM Authenticator. Standard stuff. There's links here in the slides that point you to all of them. So if you're familiar with this, finding the software, it doesn't take very long. All of this stuff can be set up in about 10 minutes. The next step is you actually go ahead and provision a cluster. So EKS CTL has a variety of ways to do it. In the particular example that I used, I went ahead and gave a specification for the cluster, and here it is. you just feed this to EKS-CTL, it eats it, and it spins up an EKS cluster. So what this is saying is that we're going to be using M5 large instances, and a little bit about the like the numbers of of them that we'll tolerate. This is all the information that we need to give it, and the cluster will come up and it'll already be usable. The next step is, and this is necessary in EKS, with the CSI drivers are the storage provider, or basically handle storage in Kubernetes. And as of Kubernetes 1.23, the CSI driver that handles EBS, which is Elastic Block Store, the cloud block storage for Amazon, has to be installed separately. So these are the commands that you need to run. You need to create what's called a service account. So basically, create the IAM role and correctly map it so that it is, or IAM policy, I should say, that is going to allow the CSI driver to manipulate block storage. And then you actually install the driver itself. EKS-CTL makes this very simple. So these two commands just take a couple minutes to run. Once you've got the CSI driver, one little gotcha is if you are manipulating CSI drivers, you need to be completely sure that your storage classes, which are the internal controllers inside Kubernetes, know that you're using EBS and that you're using this CSI driver. So you just have to have a storage class set up that has the correct provisioner name. If you just go with the out-of-box EKS, you will find that it doesn't find the provisioner correctly. So this cures that. So that's a little extra step. But again, we're really talking about 3 commands here to get this done. Next thing we want to do is add auto-scaling. You can do this in EKS using what are called node groups, but we find that they're pretty bulky. We prefer Carpenter, which is kind of a one-size-fits-all provisioner for that will both allocate and deallocate VMs, and not just one VM type, but many. It's very configurable. So it's also pretty easy to install. It has excellent documentation, which is linked here. You install it using a Helm script, and then there's a number of steps that you need to go through, ending with actually defining what the provisioner looks like. And once you've got that, you're pretty much done. And here's an example of provisioner. It's not very complicated. And there's, excuse me, you can take these examples. When you get to this point, you're basically done. Your Kubernetes cluster is ready for use. One thing that I highly recommend is that you test it out. So for example, if you're bringing up a Kubernetes cluster from scratch, unless you've done it a great deal, make sure that it actually can allocate VMs, that those VMs can get block storage. When you're doing this the first time, it's pretty easy to skip a step. And, for example, you might not have privileges to man it. You might have, made a mistake, left out the step to assign the Amazon IAM policy that's necessary to manipulate block storage. If that happens, it will just sort of spit at you when you try to bring things up on EBS. But if that test, and like you can, bring up an Nginx server that allocates volumes, and what you'd like to see is that you can allocate a VM, and that the storage gets correctly allocated, and when you take that application away, take that deployment away, that it goes away. At that point, you've got a working Kubernetes cluster, and we can begin to think about how to connect it to Altinity.Cloud. So that's Kubernetes. Now, if you're a Kubernetes person already, you probably weren't very fazed by this because it's not a super complicated procedure. There is kind of a tricky combination of Kubernetes and mixed together with Amazon Web Services technology. But if you're not a Kubernetes person, or you don't feel like that's a good use of your time, you might find this really complicated. So the question is there a better way? And the answer is yes. Starting this month, or it's actually starting this quarter, I should say, we'll be able to fully provision EKS for you. So all you have to do is give us an IAM role and a VPC, and you're off to the races. We'll have that out. We're already working with customers on that. We'll have that out shortly. So really, as long as you have a VPC that we can run in, you can set this up soup to nuts, and you don't even have to worry about managing Kubernetes itself. We'll take care of all of that. Okay, so that's the Kubernetes setup, and I want to add that's probably the most complicated part of what we did today. So let's look at the rest. So connecting to Altinity.Cloud is quite simple. First thing to do is if you don't use Altinity.Cloud, you'll need to get an account. So you can get you can fill out a trial request. We have free trials for 2 weeks. The link is shown down below. You just come in, fill in your data, we'll approve the request, and we'll provision an account for you, and it will have an environment available that is ready to be connected to a Kubernetes cluster, but since we don't know where it is, only you can supply that information. Uh, you'll need to fill that information in. So what will happen when you log in is that if you have a new account, it'll basically drop you into a page that looks like this, where it will say, hey, I know you've got it. Basically, it knows you have an environment that's waiting to be set up. And so it's just going to put you right into the workflow. And the first part is to set up this connection. And for that, we use the Altinity.Cloud connector, or well, Altinity connector. The full name is Altinity.Cloud-Connect. And so the steps that you need to follow are exactly shown here. And the commands, so you install the software, you're going to issue this command that is shown here. And there's a handy copy button. You can just go ahead and run that on your jump host. That establishes authenticates you with Altinity.Cloud, so we know you're not some interloper. And then the Altinity.Cloud connector will generate a script. It's basically creates a service account and some other couple of namespaces and some other resources. You just pump that into kubectl, and it gets applied to your Kubernetes cluster, and basically you're set up and ready to go. What do those commands look like in practice? This is a quick example. So this is downloading the software. Once you've got it and it's executable, you can go ahead and do the login, and then go ahead and generate the script and apply it to your cluster. If you're like me and a little bit paranoid, you can just say Altinity.Cloud Connect Kubernetes, and it will spit out everything that's going to do. You can have a quick look at it, or your security people can have a look at it to make sure there's nothing untoward. Once you've done that, you go back to Altinity.Cloud, press that proceed button, and it will bring you to a resource configuration page. And this is where you do some basic setup to just let us know, what resources are available for use. So you'll flip the Oz button in this case because you're running in Amazon. That helps us know, understand what the resources look like so that we can scan them correctly. But it should be correctly set when you come in. You'll list the block storage types. If we can see storage classes, we will list them automatically. You can add additional ones of your own if you'd like. Generally speaking, that's not necessary. Then you want to set up some initial node pools, and these are just saying, hey, like I have 3 zones here. I can use M5 .large machines or VMs in these, and I have up to 10 each. And I can use them for ClickHouse or Zookeeper or our system services that make Altinity.Cloud work. So you fill in this information, and then you press proceed. And what's going to happen next is you'll get shown a screen with some handsome JSON, which you can go ahead and evaluate and just double check. This is really more for our sanity to make sure that we're generating the right stuff. You press finish, and basically it starts the connection process. This process, I want to warn you, what you'll then see is kind of a connection bar come up. It'll say, hey, I'm making progress. Most times it just kind of times out after a while because certain things in Kubernetes that are required for setup, for us, for example, we have to provision a DNS name. We have to provision certificates, things like that. They're kind of slow. And so they may take tens of minutes to run to completion. This is not something related to us. It's just that certain things like DNS provisioning on Amazon is not quick. So the best thing is just to press finish. You can then just go away for a while and come back to Altinity.Cloud. And when you come back, you should see something like this. If everything is set up correctly, when you look at this environment, you will now see a dashboard which has the full information filled out, sort of stats, your allocated RAM and storage, and then your current nodes. This will just be visible in the dashboard. At that point, you've got a working environment and you're ready to go. So that's the second step, which is connecting to Altinity.Cloud. Now the off to the races step, that's the last part. So let's talk a little bit about working with clusters in Altinity.Cloud Anywhere. So once you're in, I think the easiest way to say this is it's cloud management. The fact that you're supplying the Kubernetes is irrelevant because Kubernetes is essentially the same in all these different locations, and we do the same things on it. So when you come in, this cluster view is the same thing that you would see if it were running in our VPC. So I have webinar demo. That's the thing we saw just a few minutes ago. That's an active cluster. I can go click that, and I can go to the dashboard and do things with that cluster. I can create a new cluster. Uh, I can do other types of things. These are two main operations that people do. Similarly, inside the cluster dashboard, you'll also see all this information, including things like connection details, monitoring, information about the types of nodes and node type that we're using, and then of course your available uh, memory and volume. And then you can do configuration, like adding users, all these operations that you do there. You can go to explore and you can issue queries through that little query sheet that I showed. There's also a bunch of DBA tools there that are super useful for detecting and solving problems quickly. You can see alerts, logs, and things like that. It's basically a complete cloud experience, just running on infrastructure that you own. So there are some differences though, because it's your infrastructure. Let's talk about a couple of them. First of all, Altinity.Cloud is pretty flexible about rescaling, and we automatically populate a lot of node types in. So for example, if you're using M6i family instances on Amazon, we'll populate all the node types in that family, and you can just use them. So when you do a rescale operation, which is where you're scaling up or down, either vertically or horizontally, what will happen is you'll come in here, and in my demo, I only see one node type because that's all that I've configured. Because I've only given Altinity.Cloud permission, if you will, to use that node type. So I'm going to need to tell it that, hey, there's more, you can do more, but this is basically to give you control over what can be done. Similarly, if we do horizontal scaling and we have additional, we're going to need to spin up additional VMs, you're going to need to have capacity for that. So if there are limits to your count or other things that you've configured Carpenter or your node pools to limit the number of nodes, this may not be possible to do until you extend those limits. In which case, what would happen is we would try to do it, and you'd see things pending, and then you'd look underneath and you'd see, hey, we've got pods that are waiting for nodes that they can run on. So what you can do within Altinity.Cloud is add node types. That's pretty easy to do. So you go back to the environment dashboard, which, the picture of your Kubernetes cluster, there's a little button here that says manage node types. You press that, you can see the existing node types you have and what they're used for. And then you can just punch this add node type, and this little dialog pops up. We have a better one that's coming that allows you to, that's a little bit easier to use and has more information, but the basic idea is you just enter the names of the machine types, tell what they're used for, the memory and CPU fills in by itself, and what storage class they use, and that's it. You can add some additional labels and stuff like that, but it's not necessary for this to work. So that's how you extend the resources, and it's completely under your control. If you don't tell us that there are nodes that we can use, we won't use them. So there's no real danger of this thing going hog wild and eating a bunch of your resources. The other thing that's a little bit different is in Altinity.Cloud, we configure backups automatically. You have to help us a little bit on that. You have to come in. So again, this is something you get in the environment, in that environment pane. You can go in and you press edit, and then you can set up the backup configuration. So that's this tab right here. You first of all turn them on, set a backup schedule. This is a new feature in Altinity.Cloud that we can basically set these very configurable features. What I've done is set this up and said, hey, I want three backups, run them every day at 5 a.m. and keep at most three of them. And then you're going to have to give us some information about where to store the backups. It's basically an S3 bucket. So this is fake information, of course, but give an access key, a secret key, and region, bucket name, and path if you want. Otherwise, we'll supply one. So that's it. And at that point, you can back up and restore your clusters in Kubernetes. It's a really cool feature. So and there's a create backup command off the dashboard. They'll run automatically, but you can create them anytime you want yourself. So you can just hit create backup or create backup, and it'll go ahead and run kick off the backup. And then you can come in later if you want to restore it, and it'll show you all the backups that it's run. Those are just a couple that I ran manually, and they're pretty small because this is a new cluster. So that's another thing that's a little bit different. Again, once it's configured, it behaves just like ordinary Altinity.Cloud. And this, I personally find a super convenient feature because backups are one of those kind of painful things that you just want to get right and sort of fire and forget it. This does that. What else? Well, because this is your own cluster, there's a number of other things, and to a certain extent, it's up to your own imagination. But here are three things that we have worked with customers on. The first is setting up private connectivity. So ClickHouse.Cloud supports VPC endpoints. You can enable those. It is a very simple operation, but we have to enable it in the background for you. It's not available in the UI yet. So you can just contact us for support. We'll help you do that. You may want to run other applications in that ClickHouse cluster. Sometimes you have the ClickHouse cluster, but you're using it, or excuse me, Kubernetes cluster, but you're using it for other things. We can advise you on how to do that safely. Basically, we just use two namespaces. We cannot see other namespaces. We cannot manipulate their contents. So, as long as you keep things separated, it should work. But there's some issues with doing things like provisioning new nodes where you need to do some configuration like adding taints or selectors, which we can advise you on. And that's to prevent these from treading on each other and you trying to, when you're allocating resources. And then finally, there's DR, which we have worked on with at least one of our customers. Some people want to use this because they control it. They'll want to set up a DR cluster. That is possible to do. It's involves a fair amount of legwork. Again, we can advise you on how to do that the best way. So for any of these and other questions, just contact support. We'll talk about that at the end. There are some advanced topics here, which I'm just going to touch on very lightly, but in the interest of time, keep going so that we conclude in a timely fashion. The first is just what's going on down there. So, and this is a somewhat complex picture, but basically you have two kinds of things running inside that we run inside your Kubernetes cluster. We have the ClickHouse clusters themselves, and we use Zookeeper. We still have not switched over to ClickHouse Keeper because it still has some production issues that we're not totally comfortable with. But this is your analytics stack over here on the right side. There's also the Altinity operator, which makes it run, and that and the ClickHouse clusters live in the same namespace on Kubernetes. You can go there and see them. That was the one I was looking at to see what the pods were doing. We then have a set of system services that include the Altinity connector that you installed. We have something called the Edge proxy, which is used to route traffic that comes in from a network load balancer, and then there's other system services that include Prometheus, Grafana, things like that to allow you to get monitoring and to collect information that we use for alerting. So that and the reason this is important is that if you do ever decide to disconnect from us or migrate away, or you want to take more active hand in management of all the parts that are related to your to the analytics stack, other than the edge proxy, uh, are open source completely. So you can basically disconnect us and fully, and your clusters continue to run. Moreover, if this connection fails for any reason, there's no problem as far as your apps are concerned. They will continue to work. They do not depend on active communication with Altinity.Cloud Manager. So if there's a transient network failure, it's not a problem. When it comes back, you'll be able to see them from Altinity.Cloud again. So that's what the parts are. One thing that's really important about this model is your data stays entirely in your own VPC, and we actually store very little information. We have some configuration information that you gave us when you set up, but basically for most things, we tend to look inside ClickHouse itself or inside the Kubernetes cluster to find important bits of information. Um, you have control of data, and you can actually control that. I'll show you that in a minute. So this is a quick picture, which you can look at your leisure, but this is what's going on inside Kubernetes, the resources that we allocate. If you've used the Altinity operator, you're familiar with this. It's pods, persistent volume claims, services, things like that. So it's fairly straightforward. And the cool thing about Altinity.Cloud Anywhere is you can just go look at them with kubectl uh, and see what's out there. Uh, the reverting back to that security model, you can control what access we have. This is part of, you don't just own the data, but there's a gate. And on any cluster dashboard, you'll be able to see this Altinity access button, and you can go ahead and give us no access, which means that our folks are not allowed to come in and look at your data. It basically takes that user away, or set it to read only, and we can see system database, so on and so forth, read only, and then full access. You decide. If you pick full access, this thing goes red to show that it is, it's not safe. But the idea is to give you not just ownership of the data, but control of who touches it. Final topic is how support works. And this is pretty simple. We have enterprise support for every environment. It's just part of the offering. So what does that mean? Well, it means all these things on the left side, everything from schema design to integrations, fixing bugs or emergencies that arise, and then just answering random questions. We currently have two ways of accessing support using Slack and Zendesk. We're kind of thinking a little bit about that, and it's likely we will try and collapse that into one just for simplification purposes. But the point is, you can easily get hold of us and and quickly ask questions. Important thing about questions and sort of scope of support: if you're running anywhere, of course, we will help you with Kubernetes problems, anything that's relevant to running Altinity.Cloud Anywhere. We do a lot of Kubernetes work. It's our entire cloud is based on it. We manage a couple hundred clusters. So we'll, of course, if there's something that's not working in Kubernetes, we'll of course help you diagnose. Well, that's affecting Altinity.Cloud. We'll of course help you diagnose it and fix it. And just some standard advice about how to. This is true of any Altinity.Cloud. There are ways that you can make that support work better for you. I think the biggest thing is talk to us before you have a problem. And we do, because we have the connection, we can actually be very proactive about your data. So for example, if you're inserting data too fast and in blocks that are too small, we can see that, and we'll typically give you a yell that, hey, we're seeing errors, or we're seeing problems with your cluster. But generally speaking, like if you have big upgrades planned or other things that you're doing that will change the load on your system or change the use profile, it's a really good idea to give us a yell, and we're happy to answer questions about it and give you advice about about what's going on, that also enables us to plan in case, just so if we know you're like planning a big upgrade on Saturday night, we can keep an eye out for problems. So that's that's Altinity.Cloud Anywhere. It's really like Altinity.Cloud itself, the one that we've been offering for over 2 years. It's just that it's your Kubernetes and your VPC, and you own the data. So what I like to think about with this is it's really giving you cloud control, cloud convenience, which everybody wants. That's been big since Oz came out and did things like Redshift that meant you could get a data warehouse in a few minutes. But at the same time, it gives you the control of installed software. I mean, we don't want to go back to these hairy installs, but we do want to have some of the other things that those installs gave us, like control of data, control of infrastructure, the things that enable you that are important for your business and to make your app successful. Very important. You may be wondering how much this costs. Talk to us. We're still working on the pricing model. We do have numbers, but the key thing here is it's based purely on compute. We do not charge for data or anything else for that matter that you're doing inside that Kubernetes cluster. It's simply based on the amount of compute you apply, and the prices are very reasonable. So you can have a huge amount of data, but if you're not doing anything, if you're only running a small number of instances on it, or have queries that run once a day, that you're going to pay for the resources necessary to run those queries and nothing else. You can run ClickHouse anywhere that Kubernetes runs. As I say, EKS and GKE are the ones we're most familiar with, but we're actively moving to support others. Azure, we're talking with folks about Azure, and as well as DigitalOcean. And then Red Hat Redshift is also on the list, and will be added at some point this year. And then finally, if you're not a Kubernetes person, no problem. We're developing. We know that many people, we like Kubernetes, we're familiar with it, but for many people, you just want to get on with work. We have the ability to install it fully, and that'll be rolled out over the next few weeks to anybody who's interested in it. So we can basically take over that part of it as well. If you like what you heard, what I'd like to recommend is come on down and start a trial. It's pretty simple to get signed up. Costs you nothing for the first 2 weeks, and gives you access not just to the software, but also gives you a taste of what the services are like, so that you can basically use this and try it out. And that's it. So I want to thank you all for attending, and I do apologize for the mix-up that we had on the getting started. We'll go back and try and understand what happened there. So with that, I'll open it up. If anybody has questions, I'd be happy to answer them. We'll stick around for a minute or two. We also have Alexander Zaitsev, who's the person who really drove the development of all this technology, which is quite amazing. I've been working with these systems for a long time, and this is the first time I've seen one that works as well as this. And I hope that you guys will try it out and also have that experience. I want to, if you're departing, I want to wish you a great day. I hope this has been interesting, and do contact us. We'd love to work with you and see how this can help you build real-time data. Thanks.